Right now, 12 billion miles from Earth, there's a second spacecraft slowly running out of power. Its sibling already made headlines for nearly dying. This one is next. And unlike Voyager 1, we already know roughly how the story ends, because NASA is the one ending it, instrument by instrument, on purpose. This is Voyager 2, and this is how it's going to die. Most people don't know Voyager 2 actually launched first on August 20th, 1977, 16 days before Voyager 1. It took a longer, slower route, which is why Voyager 1 ended up overtaking it and becoming the farthest. Part of that is simply trajectory. Voyager 2 took a longer, slower, more complex route through the solar system, a carefully calculated path that used the gravitational pull of each giant planet to slingshot it toward the next one in a maneuver so precise, it only becomes available once every 176 years. NASA engineers called it the Grand Tour, a planetary alignment so rare that missing it would have meant waiting almost 2 centuries for another chance.
Voyager 2 was the one that was chosen to do the Grand Tour.
They didn't miss it. Between 1979 and 1989, Voyager 2 became the only spacecraft in all of human history to conduct close flybys of all 4 outer planets: Jupiter, Saturn, Uranus, and Neptune. In just 10 years, it rewrote our understanding of the outer solar system. At Jupiter, it discovered active volcanoes on the moon Io, the first active volcanoes ever found anywhere beyond Earth. At Saturn, it confirmed the extraordinary complexity of the ring system. At Uranus, it discovered 10 previously unknown moons and found that the planet's magnetic field was tilted at a bizarre angle, completely unlike any other planet we knew. And at Neptune, the final stop, in August 1989, it revealed a dynamic, stormy world with the fastest winds in the solar system, a massive dark storm feature later called the Great Dark Spot, and a moon called Triton that orbited backwards, geologically active, with nitrogen geysers erupting from its surface. Every single image we have of Uranus and Neptune up close, every piece of data that taught us what those worlds are actually like, exists because of Voyager 2, because of this one spacecraft, on this one journey. That will never happen again, not in any of our lifetimes. That's the thing about Voyager 2 that tends to get lost in the shadow of its more famous sibling. It is, scientifically speaking, the single most productive deep space mission in history. It didn't just visit one planet, it visited 4 back-to-back and changed what we knew about each of them. Then it kept going, past Neptune, into the unknown. For 2 decades after Neptune, Voyager 2 kept traveling, kept transmitting, kept returning data. But then, on November 5th, 2018, something changed. Voyager 2 crossed the heliopause, the boundary where the sun's solar wind finally gives way to interstellar space. It became only the second object ever built by humans to leave the solar system, following Voyager 1, which had crossed the same boundary 6 years earlier. And what it found on the other side was strange. Scientists had models for what interstellar space should look like. They had predictions. They had decades of theoretical frameworks built on the best physics available. Several of those predictions were wrong. The universe, it turned out, was weirder than the textbook said, and we only knew that because of 2 aging spacecraft. Then, on July 21st, 2023, a routine command from ground controllers caused something unexpected to happen. The sequence sent to the spacecraft inadvertently caused Voyager 2's antenna to tilt by just 2 degrees off its normal position. 2 degrees doesn't sound like much, but at 12 billion miles away, 2 degrees is the difference between hearing a whisper and hearing nothing at all. Voyager 2 was no longer pointing at home. It could still receive commands in theory, but only if those commands could somehow reach it through an antenna that was no longer listening in the right direction. The spacecraft went silent, not because it broke, not because it died, because it was no longer pointing at us, and we had no way to tell it to turn back around, because turning back around requires it to hear us first. For over a week, humanity's most distant working antenna just drifted, deaf, into the dark. Here's the part that sounds like science fiction, but isn't. They used NASA's Deep Space Network, the array of massive radio dish antennas positioned around the globe, the largest and most sensitive civilian communications system ever built, to transmit a signal at maximum power, aimed directly at Voyager 2's last known position. The signal wasn't a precise targeted command. It was more like a shout into a room where someone might be standing, an overwhelming burst of energy, hoping that even with the antenna tilted 2 degrees the wrong way, some fragment of the signal would still reach the spacecraft's receivers. The team called it an interstellar shout. Then they waited. 2 days later, the time it takes light itself to make the round trip. Voyager 2 answered back. It had heard them. It corrected its angle. It found Earth again. A 46-year-old spacecraft 12 billion miles from Earth corrected its antenna angle, found Earth again in the sky, and resumed contact as if nothing had happened. But here's the truth nobody wants to say out loud. That was a temporary scare. The real ending isn't a malfunction, it's something much simpler and unstoppable. Voyager 2 runs on a radioisotope generator, fueled by decaying plutonium. It loses about 4 watts of power every single year. Forever. There's no fixing that, no software patch, no interstellar shout that solves it. So NASA has been doing something quietly brutal, switching off Voyager 2's instruments, one at a time, just to keep the rest of it alive a little longer. The cosmic ray instrument, the plasma instrument, each shutdown is permanent. Each one is a piece of its mind going dark, on purpose, so the rest of it can keep speaking just a few more years. Engineers estimate that by sometime in the late 2020s, Voyager 2 will no longer have enough power to run a single instrument. It will still be flying, still be out there, but it will have nothing left to say. And then, even after the last signal dies, Voyager 2 won't stop. It has no brakes, nothing to slow it down, no force in the outer reaches of interstellar space large enough to pull it off its current trajectory. It will simply keep going, forever, essentially, on a human timescale. In about 42,000 years, Voyager 2 will pass within 1.7 light-years of a dim star called Ross 248. It won't be close enough to be captured by its gravity. It will just pass by. In roughly 296,000 years, it will drift past Sirius, the brightest star in our night sky. Close enough that, if anyone were watching from the right vantage point, they might catch a brief glimmer of reflected starlight from a piece of metal humanity launched in the 20th century. And it will keep going after that, long after our sun has expanded into a red giant. Long after the constellations we recognize have shifted beyond recognition from stellar drift. Long after any geological record of human civilization has been erased by time. Voyager 2 carries a golden record, a 12-inch gold-plated copper disc designed to survive in space for 1 billion years. On it are 116 images of Earth and its life forms, greetings in 55 human languages, the sounds of rain, thunder, surf, and wind, a baby crying, a mother's first words to a newborn, whale songs, 90 minutes of music from cultures spanning every continent, Chuck Berry's Johnny B. Good, which Carl Sagan reportedly said was included because teenagers all over the world could relate to it. A joke, but also a kind of beautiful act of cultural honesty. This is us, this is what we sound like. This is what we thought worth saving. That record has no intended audience within any time frame we can realistically imagine. It is, functionally, a message in a bottle thrown into an ocean with no shore. But it exists, it's out there, and it will outlast every human being alive today by orders of magnitude so large they stop feeling like numbers and start feeling like philosophy. Voyager 2 didn't die in 2023. It just got a warning shot, a reminder of exactly how close to the edge it's always living. Its real ending isn't going to be sudden. It's going to be slow, quiet, one switched-off instrument at a time, until one day there's simply nothing left to switch off. We'll lose contact with it for the last time in this decade.